All right, continuing into part 2, where we'll go to applications of systems of linear equations in two variables. Now, in your notes, you should put part 2 clearly and then highlight that. And then under that, you're going to put example 7. Now, take a few moments to read the question, and then we'll go into the solution in some detail. So a metallurgist needs to create 30 kilograms of a 40% copper alloy. He must do so by melting 20% alloy and 50% alloy and mixing them together. How much of each alloy will he need to make what he needs? Now, as we go to the solution of this, we'll take a look at defining our variables. And they do a nice job, so this is what I would copy. Let X be the amount of the 20% alloy. So you're going to get from this then 20% of X. Now that's the beauty of algebra. We don't know how much the X is. Now let Y be the amount of 50% alloy. So 0.50% of Y. Now, eventually, what do you want to make out of this? Well, you want to make a 40%. So this is going to be equal to a 40% mixture of how much do you want to have all together? Well, you want to have 30 kilograms. So there's one equation. Now, since this is systems of equations, how will we represent another equation? Well, here's the amount of X that we need. Here's the amount of Y that we need. And eventually, this is going to equal our 30. So these are our two equations. And of course, this is what they bring in down below. But what I'm going to do now is switch to the whiteboard and work this through. And this will be a test, in a sense, of all that we've been learning so far. Let me get rid of these. There's our two equations. So what do we do first? Well, looking at this equation, I see I have lots of decimals. So I'm going to multiply the whole thing by 100, which just moves the decimal point over 2 places. So now this will become, and I'll put it over here, 20x plus 50y equals 1200. And this, and again, you could use a couple of systems. Let's do this one by substitution. Let's solve for y here. Y is going to equal, when we transpose the x, a negative x plus 30. So now that I have a value for y, I'm going to take this value and put it where the y is in the other equation. And hopefully you're following along with what we're doing. So this now becomes 20x plus 50 times our value for the y, a negative x plus 30, equals 1200. So working this through, 20x minus 50x, and then 50 times 30 is plus 1500, equals 1200. Grouping our like terms here, we get a negative 30x equals, now when we bring our 1500 over to this side, it becomes a negative 1500. So this becomes a negative 300. Going to divide both sides by a negative 30. And we get then x equals 10. Now if x is 10, what will y be? Well, 10 plus 20, and there'd be different ways to do this. So in a sense, we've identified the x then as the 20%. So we'll need 10 kilograms of that and 20 of that to give us a mixture of 40% of the 30 that we need altogether. Wow. All right, let's take a look back at what the board is going to show us. And hopefully you have this in your notes. And there is the solution from the textbook. And of course, this is what we have as well. Okay, now it just took almost 8 minutes to do this one example. These do take a time, careful reading, analysis, but this is the model of what we'll use to do what we call mixture problems. Now in this next example, which will be example 8, this is dealing with an interest problem. And here we need to know the formula for interest. Interest equals principal times the rate times the time. So this would be the money invested. We usually convert the percent to a decimal, and t refers to years. And this will give you interest, which is money gained over this period of time. The first thing we need to do is read the example carefully. So again, pause, read it. Now, basically, we're going to define, let's say, the 7% as the x value, the 12% as the y value. And this is where using two equations are so helpful. And I'll put it up here, so, well, over here. We know that x amount at 7% plus the y amount at 12% is equal to $40,000. Now, the next part is similar to what we did already. 7% of x plus 12% of y is going to give you the amount of interest that she wants to make, which is 3550. And there are two equations. So this one wasn't too difficult. Again, similar to what we did already. Let's go to our whiteboard. We want to keep that. There we go. So, what's next? Well, we did the other example using substitution. We're going to do this one by elimination, just to show you the two methods. So we're going to multiply every term here by 100. I have to add 2 zeros to do that. So this is multiplied by 100 becomes 7x, and then multiply this by 100 becomes this. Now we want one of these to cancel out. So for instance, if this x here became a negative 7x by multiplying everything in this by a negative 7. And I'll rewrite this so it makes it a little clearer. So let me pause. So I use my calculator for this and copy it step by step. So I multiplied each term here by the negative 7. And the goal was to get this x term so that it would cancel out with this x term and line them up. Normally I would put this over on the side and this here so we can see it sequentially. And then when I did the subtraction, I end up with 75,000. Divided both sides by 5, I get y is 15,000. Well, if this is 15,000 and x plus y is 40,000, you can see that x is going to be 25,000. And as we go back to our regular screen, we'll see that, and I'll clear this up so you could see it better. There is our answers. So again, they used elimination for this too. And you can see the work here laid out very well. Again, you had to keep in mind what you had for the x value, that was the 7%, and the y value, which was 12%. But again, using two equations, x plus y equals the total, and then this portion of x, this portion of y, gives you this amount of interest. All right, let's go on to our last one, I believe. Now, for example 9, we're dealing with what is called a work problem. And it's similar to the ones we've done. Again, we need to read it carefully. Working his way through school, 2 part-time jobs. So right away we know it's going to be x for one job, y for another, and that's going to be 25 hours. Now let's say that the x job pays $7.50. The y job pays $8.40. So this would be 7.50 750x plus 8.40y equals his total salary, and we want to know how much time for each. So again, I would get rid of our decimals. And there are our basic two equations. Now, a couple of ways to do it. Could use substitution that we did before, but let's just follow, and you're going to copy this into your notebook. I could write it out, but here it's laid out very nicely, and I think you follow how we did it. So here they're going to multiply, again, a little differently, but that's all right. I would multiply this one by, they're multiplying it by negative 75. Here they're multiplying it by 10. Again, there's slightly different ways to do it. And if we're going to copy this one, we'll follow this one. So here's the actual work. Pause, take a moment. Notice these become negative, so the x's will then cancel out. You're left then with a positive 9y equals 1, 2, 6. Divide both sides by 9. Y equals 14. Now, if y equals 14, and we have 25 hours, subtract 14 from 25, and you get 11. So again, the x is the 750, so 11 hours at job A. The y is 840, 14 hours at job A. And you've used systems of equations to solve this type of application. Now, there are graphing calculators that help solve systems of linear equations that the book goes into. And if you have one of these TI 83s and 84s and 85s, they can be used to solve. Now, normally in MATLAB, you wouldn't be able to use this type of calculator to do the calculations. You'd have to do it with a basic calculator. And I believe this will wind us up. And just this part took under 20 minutes for 3 examples. Hopefully, good background skill.